festival, shoe carnivals, the shoe carnival, shoe festival is already finished also.
What?
The shoe carnival, shoe festival.
Yeah, we're gonna start from there.
Okay.
So last class we were talking about these two shoe shops that are in the same town close by, and they have to decide whether to sell for a high price or a low price, right? And we said that if they, you don't know what the other person is doing. So if Shoe Festival decides to sell it for high, but Shoe Carnival sells it for low, what's gonna happen is Shoe Carnival is gonna make a lot more profit, and Shoe Festival, because it's charging a high price, is not gonna sell a lot of shoes. So there's a danger of being in this spot where Shoe Festival decides to sell it high, but the other one decides to sell it for low and makes more profit. So to avoid that, the Nash outcome, or the Nash equilibrium, in which means is you're thinking like Nash, you're thinking like what the other person might do, the safest would be to sell it for low, because if they both sell it for low, they'd be making 25 and 28, reasonable. And if one sells it, and if Shoe Festival sells it for low, and the other one sells it for high, so Shoe Festival sells it for low, they'll be making 50,000 in profits. And if they choose to sell it high, they'll be making 13,000, so they're way ahead in profits. So by selling it in low for Shoe Festival, it's the best option. It doesn't matter what the other one does. You see how when Shoe Festival sells it for low, it's the best option. Both profits are decent profits. Doesn't matter what Shoe Carnival chooses. If Shoe Carnival chooses high, well, it's like a holiday for Shoe Festival. They'd be making a lot more. If they choose low, still it's gonna be reasonable competition. Both will be making reasonable money, right? So is this a dominant strategy? Yes, it is a dominant strategy, because it doesn't matter what the other person is gonna choose, you're still gonna choose selling low, right? Because Shoe Festival could be here or here, it doesn't matter. They're both best options. They're both avoiding this one, right? The nasty one where they sell it for high, but they're selling it for low and making more profit. So it doesn't matter what the other person is doing. This is the dominant strategy. Selling it low is the dominant strategy for Shoe Festival. Or even if you think about Shoe Carnival's position, the same thing is true. Selling it low is the dominant strategy. Is there a prisoner's dilemma? Yes, there is a prisoner's dilemma, because we don't know what the other person is doing. Prisoner's dilemma is when you don't know what the other person is doing. It's basically named the reason why it's called prisoner's dilemma is when two convicts go to jail, right? They are set down separately, and legal people or police or whatever sit down with them, and they ask them, your partner, you have to think about your future. Are you going to confess or not confess? Now, this is why it's called prisoner's dilemma, because they don't know if their crime partner is going to confess or not confess, right? So we use that term in game theory as well, that this is prisoner's dilemma because they don't know what the other company is doing. So yes, there is a prisoner's dilemma here. The next one that we're going to talk about is, we're going to do one more example like this. Okay, let's do that and then. So everybody understands what's the dominant strategy here? And what is the Nash equilibrium outcome? Both will keep it low, right? The dominant strategy, yes, it is a dominant strategy because either way, it doesn't matter what the other person chooses. They're both better off by keeping it low. And third, is there a prisoner's dilemma? Yes, there is, because they don't know what the other person is doing, right? Okay, let's do one more. By the way, Wednesday will be your quiz. So next class is your quiz first, and then we'll do lecture, finish up. So Monday is your last class, right? Monday you might have a quiz, I'm not sure, depending. If we don't have a quiz, I'll just hand it to you for studying. So, but definitely Wednesday you're gonna have one. So now let's do another one of these game theory things. Airbus and Boeing are deciding whether to charge high prices or low prices. So we'll call this one Boeing. High price, low price. This is high price, low price. So profits for Boeing are $3 billion. Here. Profits for Airbus at this position would be $4 billion. Okay, now I want you to do this on your own, okay? What is the Nash equilibrium? Does it present prisoner's dilemma, and is this a dominant strategy? Answer these questions, okay? What's the Nash outcome? represents Prisoners Dilemma. Is this a dominant strategy? Okay, so what's the Okay, so what do you guys have? So, both don't know what the other person is gonna do, right? If Airbus sells it for high, they're gonna make 4 billion. If Boeing is also selling it for high. So if they both sell it for high, Airbus will be making 4 billion, Boeing will be making 3 billion. If, however, Airbus sells it for high, makes the decision of going for high prices, and Boeing decides to go low, Boeing is gonna take all the customers, right? When they're selling it for cheap, everybody's gonna buy airplanes from Boeing. So then Airbus is in a bad position. So what happens? To avoid this kind of position where Airbus is selling for high and Boeing takes all the customers, the best strategy would be for Airbus to keep it low. If they keep it low, Boeing keeps it high, this is like the best option ever, right? If they keep it low and Boeing keeps it high, 3 billion, that's the best profit. Even if they keep it low and Boeing keeps it low, it's better, 1 billion is better than this 0.5 billion, right? So this, keeping it low for Airbus, is the best strategy. And the same is true for Boeing. So from both perspectives, you will arrive at the same conclusion that keeping it low is the best strategy. So is this a prisoner's dilemma? Yes, both don't know what's the other doing. Is this a dominant strategy?
Yes.
Yes, keeping it low is better off, despite if Boeing keeps it high, well, it's really good for Airbus. If they keep it low, even it's better than being in this position. So yes, yes, and keep low, right? Okay, now what if, so this was game theory, Nash equilibrium. There's also a sequential game theory in which one party can make the decision first. So in sequential game theory, one party, so either Airbus, so in our example, Boeing will get to make the decision first. And they have an advantage over Airbus because they get to make the decision first, and they can assess that if I choose this, what are they gonna choose? So it'll make sense when we do it. So same kind of Boeing Airbus example, but in a sequential game theory. Let's see how that works out. So in a sequential game theory, one party gets to decide first.